Hello, this is Mr. Burgess, and today we're going to be talking about translating equations from word problems into written problems that we can solve. Now, let's just remember a couple of problems we solved in a recent homework, a couple of problems about how to solve a multi-step equation. So this first one in our bell work is to use the distributive property to distribute the negative 3 to each number inside the parentheses by multiplying. So negative 3 times x would be negative 3x. And negative 3 times 4 would be minus 12. And all of that's going to equal the 9 that was already on the right side. So now we've got to go through a little set of operations, inverse operations. So we're going to add 12 to both sides. And by doing that, we end up with 12 plus 9, which equals 21. And all of that equals the negative 3x we had left over on the other side. So now when we divide both sides by negative 3, divide by negative 3, and I'm kind of scrunching it in there, sorry. So I end up with a final value of x equals 21 divided by negative 3, which is negative 7. So there's an equation that we had to solve using the distributive property. Now here's one where you had a little bit more going on. So let's clear our screen off and try this one. So here we got to use the distributive property, 2 times r and 2 times minus 3. That'll give us 2r minus 6 minus 5r equals 3. So if I combine the 2r minus 5r, I end up with minus 3r. Then the minus 6 that you see there, I'm going to add 6 to both sides. And those will cancel each other on the left side, and on the right side we end up with 6 plus 3, which is 9. Now we're going to divide both sides by negative 3. And that gives us a final value of r equals negative 3. So there's our second bell work problem, multi-step equation. Okay, so today we're going to talk about expressions and equations and how we can write them from a word problem. I know everybody's favorite. So remember, an expression is just numbers, symbols, and math operations grouped together that show the value of something, like 5y plus 8, 3 minus 12w. These can come in all shapes and sizes. An equation is a math sentence that shows two expressions are set equal to each other, like 8x minus 3 is equal to 13, or 9t plus 8 equals 5t minus 4. All right, so let's go on. What are we going to do with that information? So we're going to hand out some notes that give you some clues for what words go with what mathematical symbols, and you're going to glue these into your notes. So we start out with, on our first thing on our notes is words and phrases that, to math symbols, words that mean addition or in a sentence would include add, sum, increased by, more than, combined, together, and then the last couple plus and so there could be any one of a number of other ones you could think of. Okay, how about subtract? Subtract, take away, the difference, decrease by, and like a number decreased by 5, or a number of 6 fewer than a number, or 7 minus 3, or something like that. Those are all things that you would use to give you a subtraction sign. Now there's some turnaround words in there too. Like if we say than, less than any, then in that case we may actually turn the problem in the order in which it would be written around. Or for this, such as from or fewer. That's another couple of words that mean turn around the phrase. And we'll explain more in a minute. So multiplication, so multiply times of product twice or 3 times a number would be the twice it or multiply it by twice. Okay, division, words that mean division are quotient, ratio, per, divided by, and in some cases maybe even the word percent for some types of divisions. Okay, equals. So how do we get an equal sign when we're looking at these phrases? Well, if it says equals or is or are, were, will be, uh, these are all words and phrases that give us the idea of putting an equal sign in our equation. So let's write a few expressions and then we'll write some equations. So this first expression is the quotient of k and negative 12. So that means I'm going to start out with k, and then I'm going to divide it by negative 12. Okay, it's divided by negative 12. There we go. So that's what it would look like. The difference of 9 and z. So the difference of 9, difference means subtract, so 9 minus z. Okay, keeping going. How about 8 increased by w? So 8, the number 8, increased by, which is addition, and w is a variable. 3 subtracted from, there's that one of those switch around words, from twice g. So twice g would look like this. And then 3 subtracted from that, we just go minus 3. And that would give us that expression. Okay, translate these phrases. 4 plus the sum of w and z. So 4 plus the sum of w and z. Now in this case, there might actually be some parentheses that will be needed there. Now twice the difference of a number and 6. So twice the difference of a number and 6. So a number and 6. These are the kind of words where we could, and phrases where we could end up with some parentheses as well. Okay, now we're going to write a few equations, which means that after the expression, we're going to have some kind of an equal sign. So the quotient of x and 5 is 12. So if we remember, the quotient means divide. So x divided by 5 is 12. All right, 9 less than y equals to negative 30. So if you have negative 30, and then you're going to, so that's going to be equal to 9 less than y. So 9 less than y equals negative 30. 6 more than the product of 22 and n. So in that case, that means multiply. So we're going to multiply 22 and n together. And then we're going to add the 6 to that. And that's an expression, that's not an actual equation in that case. So, okay, so there's a few samples. What else could we be looking at? Well, there's a couple more examples. 12 increased by twice w is 20. So 12 increased by twice w is 20. Okay, the product of 7 and x. So the product of 7 and x decreased by 3 is 18. How about evaluate? We're going to evaluate this expression, so we'll go ahead and stick in the numbers that we give you, 31 and 6. So 31 goes in for x, and 6 goes in for y. So that's going to end up being 31 So let's keep that going again. So we got 31 minus 3 times 6, so that's just going to be 31 minus 18. And you can use your calculator to do that, or if you don't have one, you might have to do something else. But I know that 18, you add 18 to 2, you get to 20, plus 11 more to get to 31. So that gives us an answer of 13. 13 plus 18 equals 31. Okay, evaluate the expression when m equals 4 and n equals 5. So 7 times 5 plus 4. 7 times 5 is 35. 35 plus 4 equals 39. Okay, how about this last one here? Evaluate this expression when C is 56 and D is 31. So we're just going to plug in the numbers given for each variable. So 56 divided by 8, and 56 divided by 8 is just 7. So this is going to equal 31 plus 7, which equals 38. Okay, so that's the kind of things we can look forward to seeing today. So the name of the assignment is number 18, translating equations, and in some cases expressions. So good luck, and so a lot of the work that you're going to do is actually just showing how you translate it. So good luck.